Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, I'm super excited today because today we're rolling out the most requested feature by customers probably for the last 2 years. That feature is the ability to control an Ethernet IP network with a Horner controller. Now, Horner has supported Ethernet IP for a number of years, but only as an I/O adapter. In other words, you could have a machine that was controlled by a Horner controller, an all-in-one or one of our new modular controllers, and it could exchange data on an Ethernet IP network, but it couldn't control the network. Now, we have a number of customers who've said, hey, we like to use Horner controllers as much as we can, and we have some machines that are based around an Ethernet IP network, maybe because they were originally controlled by a Rockwell. And they would like to be able to transition away from the Rockwell PLC and to a Horner controller instead. And that could be for a variety of reasons. Of course, the Horner is much less expensive. Software is much less of a hassle. Our lead times are much shorter in a lot of cases. So there's lots of reasons to switch to a Horner controller, but they need the ability to control devices over Ethernet IP. So today we're rolling out that capability. Officially, it'll be launched in April, and it's currently the end of February, but that's just a few weeks away, and I've been working with this feature for a number of weeks now, and I'm really comfortable with where it's at. So we're gonna show it to you today. All right, after all that excited introduction, let's go ahead and get started. Okay, as you'd expect, we'll do a quick review of Ethernet IP, and then we're going to dive right into showing you how to use the new Ethernet IP scanner capability with a Horner controller. And yes, Ethernet IP scanner is what it's called when you are a device that's controlling an Ethernet IP network. We'll also talk about what models of the Horner controllers support this new functionality, and there'll be plenty of hands-on demonstrations. Here we go. All right, so what is Ethernet IP? Well, Ethernet IP is the most prevalent industrial Ethernet network in North America. And that's in large part because Rockwell, or Allen Bradley, has a large market share in North America, and Ethernet IP is the network that they are basically pushing, if you will. Now, even though it's often associated with Rockwell, it is an open protocol that is governed by an association called the ODVA, and that's been around since the DeviceNet days. And speaking of DeviceNet, Ethernet IP is based on the same messaging or the same, underlying protocol as DeviceNet was, and it's called Common Industrial Protocol, or CIP. Now, DeviceNet always had a reputation for being slow, and that's because there was a lot of overhead in the messaging, and that was really more than what CAN was designed for. CAN is the chip that DeviceNet ran on. Protocols such as CAN Open and Horner's own C-SCAN protocol have much more appropriate protocols for that hardware and are still in heavy use today, whereas DeviceNet has kind of faded away. However, there's nothing wrong with the messaging on DeviceNet, and once that has been ported to Ethernet in the form of Ethernet IP, well, the performance issues pretty much went away. Now, one of the selling points of Ethernet IP is that it utilizes standard Ethernet components. And that's not universally true with all industrial networks. For instance, EtherCAT and Profinet IRT are two very clever networks, but they both rely on custom Ethernet components to operate, which Ethernet IP does not. Other networks that require or don't require custom hardware for Ethernet include, Modbus TCP, all the non-IRT versions of Profinet, and there's others as well. Also, something you should know about Ethernet IP is it utilizes both TCP/IP and UDP as message types, and we'll go into the details on why that's important a little bit later. Okay, now Ethernet IP is based on an object model, and I'm showing you a diagram there on the screen. So it's the gray box is a SIP node. Remember, SIP stands for Common Industrial Protocol. And of course, it's made up of objects, and the objects contain instances, and there's also classes of objects, and there's attributes. So again, I'm not going to go into the detail, but that's the object model that SIP is based on. Okay, now let's talk about one specific object, which is pretty important, and that's something called an assembly object, which is kind of a super object. So this is the convenient way of transporting data between devices over Ethernet IP. And you have something called an input assembly. That is basically data that's moving from the devices on the network to the controller of the network. And then you have something else called an output assembly. That's data moving the other direction from the controller of the network to the devices on the network. So again, the assembly objects are an important concept to remember when it comes to Ethernet IP and data exchange. Also important to understand is that Ethernet IP attempts to standardize things like application objects and device profiles. What's that all about? Well, it's really all in an effort to get manufacturers to conform to kind of some common data formats and to some common sets of data for similar type devices. In other words, if you have a variable frequency drive that supports Ethernet IP, whether you buy it from one of 6 or 7 or 10 different manufacturers that support that, you should basically have the same types of data and the same sets of data available regardless of what manufacturer is providing the drive. So that's really what application objects and device profiles are all about. All right, now let's get into those two different types of messages on Ethernet IP that kind of makes it two protocols in one, if you will. First of all, let's talk about explicit messages, which utilizes TCP. Now let's talk about TCP for a minute. What is TCP? Well, that are Ethernet-based messages that contain kind of error checking built right into them. So in other words, if you send a TCP message over Ethernet, you'll know as the sender whether that was successful or not, okay? Now from an Ethernet IP standpoint, it uses TCP for something called explicit messaging. So what is explicit messaging? Well, these are the types of messages that are used for point-to-point requests that are only sent on an occasional basis. Let me give you an example. Let's say you've got a variable frequency drive that you're communicating with. I mean, it's got hundreds of parameters, and occasionally you need to read or write a specific parameter in that VFD. Well, you would likely use explicit messaging for that. There's no reason to continuously read and write that data. You just need to, send an explicit message on exception or when you need to actually read that parameter or write that parameter. Okay, so that's a good example of where you would use an explicit message. However, for runtime high-speed data, that's where UDP is used. And UDP are the type of Ethernet messages which are typically low overhead and sent frequently. And Ethernet IP uses those for continuous real-time data. So in regards to a variable frequency drive, we're talking about things like the start-stop commands, the start-stop status, the frequency that you want the drive to move at, as well as the current frequency that is actually happening in the drive. So those are the sort of real-time I/O messages that are called implicit messages, and they utilize UDP. All right, now let's talk about the different classes of devices that are available on Ethernet IP. The device that controls the network, and we hinted at this before, is called an I/O scanner. So that's your typical main PLC on the network. And you can have more than one scanner, but you have to have at least one. The most common type of device on an Ethernet IP network is called an I/O adapter. It could be a drive, it could be an I/O block, it could be a whole number of things, but it's classified as an I/O adapter, okay? And it typically is exchanging data in real time on the network. You also have devices called explicit message clients. These would be things like HMIs or operator interfaces, which have the ability to read and write data to devices on the network for the purposes of displaying status and maybe making set point changes, those sorts of things. And then you have extremely simple devices that are called explicit message servers, which really don't do anything else except effectively respond when they're queried with explicit messages. Okay, so those are the different classes of Ethernet IP devices. Now, from a Horner standpoint, as I mentioned in my open, we have traditionally supported I/O adapter functionality with Ethernet IP. Again, the ability to exchange up to 128 words of data each direction with the scanner Okay, that's really what an I/O adapter has the capability of doing, and Horner's had that functionality for some time. Now, we've also had the ability to be an explicit message client. So if you had a Rockwell I/O scanner on the network as a explicit message client, a Horner OCS, even though it has full control capability, could exchange Rockwell tag data and use that for displaying on the screen or maybe adjusting set points, those sorts of things, using it like kind of as a virtual HMI device. So really, all Horner devices of any modern age at all have had both the capability of being an I/O adapter and an explicit message client. But today, of course, we're introducing the new I/O scanner capability. So you no longer have to have a Rockwell I/O scanner, now a Horner controller, whether you're talking about a modular controller or an all-in-one, if they have now the capability of being an I/O scanner. All right, in addition, of course, to being an I/O adapter and an explicit message client. And specifically, now you're talking about the ability to control third-party devices over Ethernet IP using the Horner as an I/O scanner. Okay, so that's an exciting new function that we're rolling out today. All right, now which Horner products support this new Ethernet IP scanner capability? Well, first of all, the Canvas controllers support Ethernet IP scanner as standard. Okay, so if you buy a Canvas controller, whether you're talking about an all-in-one like we're showing there on the left, or the CPU 300 with it as we're showing there on the right, that product or all those products support Ethernet IP as standard. Now, you can get Ethernet IP scanner functionality in the XL Prime series, but you do have to purchase a one-time license, okay? And that is very modestly priced at $249 US list, okay? So those are the products today that are supporting Ethernet IP as a scanner. Now you'll notice that the Micro series is absent from this. It's very possible that there will be some, enhanced versions of the Micro series that will also support Ethernet IP as a scanner, but that's for the future. What we're rolling out in early April effectively is XL Prime as an option and Canvas as standard. Okay, so what are the features of this new Ethernet IP scanner? And don't worry, we're going to get a chance to demonstrate these for you. Well, first of all, the Ethernet IP scanner in the Horner controllers allow you to control the Ethernet IP network. You also have the ability to exchange I/O data in real time at high speed with I/O adapters from third parties on the network. You can, in the process of configuring the Seascape for the devices that you're going to be talking to over Ethernet IP, you can get the information on those I/O adapters from the manufacturer's EDS file, if those exist, or if that manufacturer doesn't provide an EDS file, then you can configure manually Seascape for communicating with that particular device. And in addition to that real-time I/O data exchange, you also have the ability to configure explicit messages in Seascape so that you can trigger occasional messages, for instance, maybe for reading or writing a parameter to a variable frequency drive. So that's functionality you have as well. And we're going to demonstrate both of those for you today. So what does the workflow look like for configuring the Horner Ethernet IP scanner functionality? Well, you're going to go into your normal hardware configuration. You're going to go to either LAN 1 or LAN 2. Once you pull that up, of course, you have to do your normal Ethernet configuration with IP address and all those sorts of things for the Horner controller. But then you're going to find that starting with Seascape 10.2 Service Pack 1, you're going to have Ethernet IP scanner available to be enabled, available in the list of resident protocols. Once you do that, you'll need to assign a disable variable and a status variable to your Ethernet IP scanner. The next step is you're going to start adding adapters. You're going to right-click on the Ethernet IP functionality that's listed there under resident protocols. You're going to get an option to add an adapter. Once you do that, then you're going to fill in the adapter details. And again, we're going to demonstrate all this for you. And as part of that, you're going to name that particular I/O node to a convenient name. You're going to assign the IP address, and you've got a number of other things to configure as well. And again, we're going to demonstrate this all for you here momentarily. Once you've done that, okay, then it's really just a matter of configuring the details on the input assembly, the output assembly, and the configuration assembly. Now, if you imported information from an EDS file, then this is mostly done for you. Really, all you have to do is assign a local variable to either transmit the data to the device or receive the data from the device, assign a RPI, or requested packet interval, which is the frequency at which the data is going to be broadcast, or is going to be sent, if you will. Select between unicast or multicast, unicast being much more typical, multicast used in applications where you have multiple masters, if you will. And notice also that not all I/O adapters support all of input, output, and configuration type data. Some of them are input only, some of them are input and output, some of them support all three. So again, that's more information that you'll likely get either from the EDS file when you import that, or from the manufacturer's documentation. All right, so enough of this showing you what we're talking about. Let's go ahead and demonstrate it on the bench. So here's the equipment I have for you today during today's demonstration. I've got the Horner CPU 300, which is one of our new Canvas modular controllers that support Ethernet IP scanner, at least they will, starting with version 17.4 of firmware and Seascape 10.2 Service Pack 1. It's connected to a HMI Connect touchscreen, so that's how we're doing the visualization today. And then to demonstrate Ethernet IP, we have a Encoder Products Ethernet IP compatible encoder. Thank you, Zach, for providing that. So we'll be interfacing that as an I/O adapter with the Horner controller, which is acting as the Ethernet IP scanner. Let's head to Seascape. Now, I have pre-configured my screens and my variables, but I haven't done any of the hardware configuration yet for Ethernet IP because I wanted to show off just how easy it is to do this and how quickly you can do that. All right, so let's start with going to hardware config. Okay, and we're going to go to LAN 1 because that's the network where I'm going to be connecting Ethernet IP. Now, starting with 10.2 Service Pack 1, you'll see under Resident Protocols, we have Ethernet IP Scanner available here. All right, so I'm going to check it and hit Configure, select Protocol. All right, now we have to add or assign variables for Disable, which is Boolean, and Status, which is double integer. I've pre-configured the variables, but I'll just go ahead and pick them here. Okay, Ethernet IP Disable, and then Ethernet IP Status. Those are the variables I've pre-created for this purpose. All right, so we've assigned those there. That's the configuration of the scanner. Now we need to start adding I/O adapters to our network. And to do that, we highlight Ethernet IP Scanner and right-click and select Add Adapter. Okay, and this is where we start telling the scanner about what we're going to be connected. So let's call this an encoder because that's a convenient name to describe our encoder. We need to assign the IP address, obviously. Okay, and that's the IP address we have for our encoder. All right, and then next, we can browse for EDS if the manufacturer has provided it. And typically it's on the website, and sure enough, Encoder Products has done that. They've done a great job of making their EDS file easy to find. So let's go ahead and find it now. So I've browsed to the folder containing the EDS file. There it is. Okay. It's saying, do you want to import the EDS file? Absolutely, I do. That's the encoder I'm working with today. And then I have a choice between different profiles, if you will, okay? Different I/O interfaces. And each manufacturer can provide one, or they might provide more than one. We're going to keep it simple today and just go for the I/O assembly that gives us the position. And it's literally only input data. So we're going to be receiving data from the encoder, but we're not going to be sending any information to the encoder. And there's also no configuration data required either. Okay, so that's really the beauty of the EDS file. Okay, under connection timeout, I'm just going to fix this at 500 milliseconds. Okay, we're going to give the encoder 500 milliseconds for routine communications. We'll be doing it much faster than that, but we'll set the connection timeout at 500. We'll leave the cyclic type or the trigger type alone, and then we have to assign disable and status variables for the encoder itself. So let's do that. Okay, so we have encoder disable that I pre-configured, and we have encoder status that I pre-configured, or at least I added it in my program variable window. Okay, so that's all I needed to do for my adapter configuration. Now I need to go to the input, all right, and I need to configure the data coming from the encoder. Where's it gonna go? Now what's coming back is 4 bytes of data, and this was gathered from the EDS file, so that's how Cscape knows how much data we're retrieving. Now it's much more convenient to deal with this as a double integer, okay, than it would be to deal with it as 4 individual bytes. So we're going to change this data type to double integer. Our RPI, the requested packet interval, I'm going to change that to 50 milliseconds, okay, because that's what I'm interested in. All right, and then I have to assign a local variable to house the data. You know, where's the data coming into? And again, I've pre-configured that variable name, and that is right here, EIP encoder position. All right, and in the case of this encoder, I'm done, because remember, we don't have any output data, we don't have any configuration data, and later on I'll show you what we might be able to do with the explicit messaging configuration. So that's literally all we have to do to configure Ethernet IP in the case of just adding this encoder to our network. Really, really simple and really straightforward. So I just wanted to demonstrate that for you. I'll go ahead and download it to the controller, and then we'll take a look on the bench and see how it acts at runtime. All right, now the download is complete and everything is working beautifully. Okay, I'm turning the encoder. You can see the values updating quickly. All right, and we have some status information here for you. Now for the main Ethernet IP status, that's the one assigned to the scanner, that is going to reflect the number of I/O adapters that it's communicating with, and that number is 1, which is correct. And then for the specific status for the encoder's Ethernet IP status, the lower bit of that when set means it is operating properly. If there's a value other than 1, it means there's something wrong. So as you can see, we've got a 1 there, so we're good to go there as well. Okay, so hopefully you saw that that was really pretty straightforward to configure this encoder as an I/O adapter to talk to the new Ethernet IP I/O scanner capability built into this modular controller. So in our second and final demonstration for you today, we're going to show you how to configure explicit messaging in Cscape. Now I'm going to give you a very basic example. I'm going to show you how to configure one specific message where we're going to retrieve a parameter from the device that we're talking to, which is our encoder from Encoder Products. In a more robust example, I would show you how to exchange multiple explicit messages with a device. So we'll save that for a future session. So now let's go ahead and head to the bench and configure explicit messaging. Okay, so here is my program with explicit messaging support added. So let's start from the user interface change to show you what we're talking about here. So of course, previously we had the Ethernet IP status for the scanner and also the Ethernet IP status for the encoder. What I've added here is another data field, which is going to be populated by data I retrieve using an explicit message. And this data is effectively going to be the reported state of the encoder, okay, which is what I showed on that slide. Let's go back to that slide. Okay, here is the information on where I can grab the state of the encoder via explicit messaging. I've marked up this particular slide that you saw before so that we can configure our explicit message. All right, let's go back to Cscape now and fire up hardware configuration, LAN 1. Here's our encoder. That's what we're going to configure our explicit message for. I'll double click on that and go to the explicit message tab. Okay, so we need to enable explicit message, and then we have to select what service we're going to be configuring. Now, in this case, again, I'm configuring one specific message for this particular device. If I was configuring multiple messages, some send, some receive, et cetera, then I'd be configuring this differently. But this is what we're up to today. All right, so in this case, I'm just reading a single attribute. So that's what I'm going to select from this drop-down list. Okay, get attribute single. Next, I have to fill in class, instance, and attribute. All right, so let's go back to our user documentation. Class is up at the top. You can see that there, where I found that in the user documentation. Attribute is in the chart, but there's nothing in there for instance. Well, that's because with most devices, they will just have one instance. Okay, so you'll fill in a 1 here for instance, because there is only one instance, and they don't call that out in the documentation always. So class 1, instance 1, attribute A. Now this is a get data only or get attribute only. So we're not going to fill in anything other than a 0 length for our source data, and we're definitely not going to fill in a variable here under source data. That's because there isn't any. Okay, we leave that blank in this example where we're only getting attributes and we're not sending attributes. Okay, then we have to configure a trigger bit, okay, to trigger the get attribute single. Okay, in that case, it was the little push button on the screen, if you remember from what I just showed you. You have to configure status variable, which is 32 bits that tells you if the explicit message was successful or not, or at least if it was complete or not. All right, and then there's got to be a place or a variable where the data will come back into. And in this case, it's an array of 256 bytes. Okay, that I have allocated for receiving data in. Now in my case, I'm only going to be receiving in 2 bytes or 1 word, and that's because of, again, if we take a look at our user documentation under the attribute area in the lower left, you can see that that is coming back under data type unsigned integer, and then that data coming back is between 0 and 5, which correlates to 6 different states that the encoder can be in. All right, so again, I'm expecting the first 2 bytes to be filled in with data when I request this information. And then there's also a variable that I assign that's just an integer variable that tells me how many bytes have actually come back from the I/O device. Okay, so that's what the configuration looks like. Really pretty straightforward. The trick really is finding the class and the attribute number. That's really the trick in this scenario. Okay, so now let's go back to the bench. All right, and see what this looks like at runtime. Okay, so we haven't gotten the data yet. We haven't done a single get attribute single. We haven't executed that yet, so that's why we have a state of none. If I press this, I should expect this to change to ready. Got to press successfully, which I just did. And as you can see, it changed to ready. So what it means is, if we go back to that chart, which I'm not going to do here, a status of decimal 3 means that the encoder is ready. Okay, so that's a demonstration of a simple explicit message transaction between the Horner OCS Ethernet IP scanner and the Ethernet IP I/O device. All right, now I mentioned that we're going to be rolling out this Ethernet IP scanner functionality in April. That means between now and then, there's just enough time to squeeze in a beta program. That's right, we're going to turn this feature over for a few weeks to a group of beta users that's going to let us know what they would like maybe for us to tweak between what I've just shown you now and the release date. So there won't be any major changes, but maybe some slight tweaks. So if you'd like to participate in the beta program, we'd love for you to do so. So contact us at the email shown on the screen, and do it quickly because that beta program is going to be starting right away. All right, there is an opportunity in the middle of March for you to attend Horner Advanced Training. Now, if you're a Horner user who has used Horner for a number of years, or maybe you've already been through the standard course, I would highly recommend you take a look at attending the advanced course. And the next one is available in March, and we do have slots available. There are lots of ways to interact with Horner online on our website at hornerautomation.com, on our YouTube channel where we have hundreds of videos, and you'll find the latest Horner news always broadcast or posted on LinkedIn. Okay, now next week, we've got another big topic for you, another product that we are launching, this being the new high-speed counter module for OCS-IO. Now, we've been anticipating this one for quite a while, and I'm super excited to show it off to you. Again, we'll give you all the details on all its functionality, as well as plenty of demonstrations. So join us next week for the rollout of the new OCS-IO high-speed counter module. If you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, when we talk high-speed counter, let's all get out there and do some good.